Paper 2 kicks off with a question on stats. We are looking at 9 math study students and their projects and examination scores have been recorded in this table here. And we are asked to use the GDC to write down, which means pretty much you're going to be relying exclusively on your GDC to calculate the mean project mark, the mean examination score, and Pearson's product moment correlation coefficient R. So first of all, we need to enter the information into the table. So in the first column, you're going to enter the project mark, which is X, and the second column, you're going to enter the examination score, which is Y. Now we need to go to stats, calculation, and 2 variable stats, because we've got 2 different variables here rather than frequency, and we'll end up with something that looks like this. So we can see that X, the mean project mark is going to be X bar, which is 14, similarly Y bar, the mean project score is going to be 54. In order to find the value of R, however, we're going to go to the calculations, and then look at linear regression. And if you do that, you'll end up with something that looks like this. So we're asked to find R, which is therefore going to be at the bottom here, giving us a value of 0.5. We're going to need to use the same information that we've just got from the linear regression for part B1, because it asks us to find the exact value of M and C for the line of regression. And you can see here that the coefficient of X is actually described as A on our calculator, but obviously the coefficient normally is depicted by M, so they have the same value. M is equal to 0.875. And again, in our model here, the constant term at the end is B. So comparing that with the normal, y equals mx plus c, those two will be the same as well. So therefore, C equals 41.75. In part 2, we're asked to show that the midpoint M, x bar, y bar lies on the regression line y on x. So the easiest way to do this is to take our value of x, which we said was 14, and substitute it into the line of regression. So we've now got y equals 0.875 x plus 41.75. That's just substituting these 2 values into the equation. So we want to find a value of y when x is the mean, or x bar. So we're going to substitute in 14, which was the answer in part 1, and actually work out the value, or the corresponding value for y. And what we hope is that that will be the same as y bar, which we found in part 1, which was 54. So if they're the same, then we know it lies on the regression line. So if we do this calculation, we can actually find out that that will give us an answer of 54. So because that is the same as y bar that we've worked out in part 1, then it does lie that the point M, the midpoint M, which is the coordinates x bar, y bar, does lie on the regression line y on x. In part 2 of C, we're asked to use the regression line of y on x to estimate Jerome's examination score, and we know that he got a project mark of 17. So 17 is the x value, so all you're going to do then here is substitute in. So we can make a prediction for his exam score y by doing 0.875 multiplied by his project mark of 16 plus 41.75, which is going to give us an answer of 56.6. Part 2 is slightly unusual. There are 2 marks going for it, and you're either going to get 0 or 2. But interestingly, you can argue this either way. So justify whether it's valid to use the regression line of y on x to estimate Jerome's examination score. So in the first instance, we can say yes, it is valid, but there's no points unless you actually justify it with a reason. So the reason is that we can say that there is no extrapolation. So extrapolation So we can see, if we look at the original values of x, we can see that the smallest number is 6 and the largest number is 18. So because we're being asked to make a prediction based on 17, which falls inside that range, then it will be valid. And we also need to say that the value of r, which is 0.5, is large enough. So that is the argument for saying that we can use a regression line to justify it. However, you can also get full marks for saying that it is not valid. And again, the marks, both marks really, are contingent here on the reason. So in order to say that it's not valid, you essentially need to say that r is not large enough. So if you can say anything to that effect, you will get both marks. The final part of the question looks at percentage error. So we have already made a prediction about Jerome, and we predicted in the previous question that Jerome would get 56.6 marks in his final examination score, but we're told here that he actually ended up with 65, and we're asked to find the percentage error. So the formula from the formula booklet is the modulus of VA, which is the approximate value, minus VE, which is the exact value, divided by the exact value times 100. So what does that mean here? Well, the approximate value is 56.6 minus the exact value, which is what he got, which is 65, divided by the exact value, which was 65. So we're going to work that out, and the modulus sign there essentially means that you're just going to ignore the negative sign. So you'll end up with a negative value, but just ignore the negative sign. Take that value, multiply by 100, and you will have your answer of 12.9%.